Yes, a supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
If that's the case, it was a million times more massive than the previous objects from outside the solar system, and that was puzzling. It also came in the same plane as the planets around the sun.
The announcement spread like wildfire when both Harvard astronomers and NASA researchers confirmed that 3I/Atlas, the third known interstellar object to pass through our solar system, was not only on a trajectory toward the inner planets, but was also accelerating at a rate that defied conventional models. What shocked the global scientific community was not merely its presence, but its unusual velocity increase as it headed directly toward the orbital region of Mars. The term red alert was used deliberately, rare in academic and space agency communications, because the data suggested something more complex, more alarming than a simple chunk of interstellar rock drifting through space. Before we start, smash the like and subscribe buttons for more updates. For decades, astronomers have speculated about the kinds of visitors that might drift in from the void beyond our sun's gravitational influence. Oumuamua in 2017 and Comet Borisov in 2019 were treated as scientific wonders, fascinating examples of objects formed around alien stars. But 3I/Atlas is different. Unlike its predecessors, its acceleration is inconsistent with the gentle push of outgassing ice, nor does it follow predictable gravitational nudges from planetary masses. Its motion suggests either an internal energy source or an external interaction that current physics struggles to fully explain. Harvard researchers, analyzing data through their Astrophysics Center, highlighted the sharp deviation in its path after crossing Jupiter's gravitational well. NASA's JPL teams corroborated this using deep space tracking instruments, and the numbers aligned with growing unease. This was no passive traveler. The acceleration matters because it places 3I/Atlas on a narrowing course toward Mars, with models showing increasing likelihood of interaction. While impact is not yet declared inevitable, the trajectory places the object dangerously close to the Martian orbit within a time frame that is unsettlingly short. That proximity alone is enough to trigger alarms, because the implications for both Mars and ongoing human projects there are staggering. Mars is not just a cold red desert anymore. It represents the next frontier for human exploration, the testing ground for habitats, and a key node in humanity's ambitions to expand beyond Earth. An accelerating interstellar body intersecting its orbital space raises questions not only about safety but about what exactly this object is. At the center of the alarm is the sheer mystery of the acceleration. Typically, comets gain speed as sublimating gases erupt from their sunlit sides, creating tiny thrusters that adjust their orbits. But analysis of 3I/Atlas shows no significant coma, no bright jetting tails, and no dust plumes large enough to account for the observed motion. Instead, the acceleration is smooth, deliberate in its steadiness, almost as if it were being guided by forces unseen. This leads to a profound unease. If the object is not behaving like a comet or asteroid, then it may belong to a category beyond natural astronomy. The Harvard teams were careful with their language, but their published graphs and data plots left the implication hanging in the air. NASA officials, usually cautious with public speculation, joined in issuing the alert, confirming that the numbers were solid and that the anomaly was real. The implications ripple out into every domain of thought. For planetary defense advocates, the scenario underscores just how unprepared humanity remains for interstellar threats. Earth-based planetary defense efforts have primarily been oriented toward cataloging near-Earth objects formed in our solar system. Interstellar visitors like 3I/Atlas move faster, arrive with little warning, and behave unpredictably. The possibility that one might accelerate toward Mars is a warning shot across the bow of complacency. For space agencies, it raises urgent questions. How do we monitor objects that break the rules, and how do we safeguard missions and infrastructure on Mars from forces we don't fully understand? Mars itself becomes a central character in this unfolding drama. The planet is not only a scientific target, but a political and symbolic one. Nations and private corporations have invested billions into the dream of human landings, colonies, and resource extraction. A fast-moving, accelerating interstellar object in its neighborhood could alter plans dramatically. Even if 3I/Atlas does not strike Mars directly, Its close passage could generate cascading consequences. Dust storms stirred by shock waves, impacts on Martian moons like Phobos or Deimos, or disruption of orbital infrastructure all carry profound implications. Satellites, landers, and rovers dot the Martian surface and skies, each vulnerable to debris or sudden gravitational perturbations. For a planet that has become humanity's experimental outpost, the prospect of cosmic interference is both terrifying and humbling. Harvard's astrophysicists emphasize the rarity of such a trajectory. To date, only 3 confirmed interstellar objects have been documented, and none have behaved in this way. The odds of one threading through our solar system and accelerating toward the orbit of a planet we actively explore defies probability, suggesting either extraordinary coincidence or an unseen mechanism guiding it. The latter possibility is what chills so many researchers. If forces beyond sublimation and gravity are at play, then we may be facing phenomena that extend outside the current grasp of astrophysics. Whether that means exotic material composition, interactions with solar radiation, or something far stranger remains an open question. NASA's engineers are approaching the data with characteristic pragmatism. Instruments aboard Mars-orbiting satellites have been retasked to monitor incoming space along the projected path of 3I/Atlas. Ground-based observatories across Earth are being coordinated to triangulate its position daily, ensuring no subtle deviation goes unnoticed. The Deep Space Network is pouring bandwidth into fine-tuned tracking, while theoretical teams run simulations to estimate possible outcomes of a close approach. Their internal memos, as reported in snippets, carry words like unprecedented, urgent, and unknown. This is not the typical tone of detached academic curiosity. It is the controlled tension of professionals staring at data that could alter the trajectory of human expansion into space. At the same time, the cultural and philosophical reverberations are immense. The very idea of an interstellar object accelerating toward Mars resonates with archetypes of cosmic intrusion. For centuries, humanity has gazed at the stars, wondering when the unknown would arrive at our doorstep. Now, with telescopes and spacecraft watching, we face a tangible manifestation of that wonder tinged with dread. Is it a natural body exhibiting physics we do not yet comprehend? Or is it something that challenges the boundary between natural and artificial, hinting at interstellar technologies or processes far beyond our reach? Scientists resist sensationalism, but their restraint cannot dampen the imagination of a global public increasingly captivated by the possibility. The numbers themselves do not lie. Graphs charting its motion show curves bending in ways that calculations of solar radiation pressure cannot fully explain. The margin of error shrinks with every new data point, yet the anomaly persists. The closer it comes to Mars, the more refined the tracking becomes, and the less wiggle room exists for dismissing the acceleration as measurement error. That persistence is what compelled both Harvard and NASA to issue their rare joint alert. The phrase red alert carries weight not only in science but in geopolitics. It signals that something outside ordinary parameters is unfolding, something requiring collective attention. Mars is not defenseless, but its fragility is stark. The thin atmosphere offers little buffer against cosmic debris. Its surface infrastructure, from rovers like Perseverance to the fragile experimental helicopters, could be crippled by even minor impacts from fragments associated with 3I/Atlas. The orbiters, critical for relaying data back to Earth, could be jeopardized if debris clouds emerge. The timing could not be more precarious, as international momentum toward crewed missions builds. The possibility of sending humans into Martian orbit or even onto its surface during a period of interstellar uncertainty introduces ethical and practical dilemmas. Risk assessments are suddenly more complex, colored by forces no launch schedule could have anticipated. The psychological impact cannot be overstated. For generations, Mars has represented the promise of stepping beyond Earth's cradle. To have that dream menaced by a cosmic intruder strikes at the heart of human ambition. It is a reminder that space is not an empty canvas awaiting our colonization, but a dynamic, unpredictable environment where forces beyond our control still reign supreme. This humbling realization carries both fear and a strange exhilaration. The unknown has always been a catalyst for discovery, and 3I/Atlas may become the most important teacher of all, whether through catastrophic encounter or mysterious passage. As data continues to accumulate, The world watches. Harvard astronomers refine their models late into the night, comparing trajectories with unprecedented precision, its true nature hidden within its dark, silent form. And so the story continues to unfold, with each passing day narrowing the distance between 3I/Atlas and Mars. Humanity stands at the edge of knowledge, gazing at the approaching enigma, caught between awe and dread. The red alert is not just a warning. It is a moment of reckoning with the universe itself, a confrontation with mysteries that refuse to fit neatly into our equations. Whether natural or something more, its approach toward Mars marks a turning point, a reminder that the cosmos is alive with motion, power, and secrets yet to be unveiled. The announcement that Harvard and NASA had sounded a red alert over 3I/Atlas accelerating toward Mars marked a seismic shift in how humanity perceives interstellar space. The initial shock gave way to a cascade of questions, and each one seemed to open another door into uncertainty. For centuries, human beings gazed at the sky as passive observers. Now, confronted with an object that not only wandered in from the depths of another star system, but also demonstrated a mysterious ability to gain speed, the role of passive observer was no longer an option. This was an event that demanded engagement, preparation, and above all, humility in the face of the unknown. One of the most pressing concerns was the sheer velocity involved. Interstellar objects already travel faster than typical asteroids or comets bound to the sun. But when acceleration is added to that equation, the speed approaches the kind of values that leave little time for reaction. Calculations showed that even if 3I/Atlas did not collide with Mars, the close pass would occur at such extraordinary velocity that it could easily eject fragments or interact gravitationally in ways never seen before. Mars's thin atmosphere provides no cushion, so the most fragile consequences of such interactions could play out directly on its surface. The rovers crawling over Martian dust, the delicate instrumentation measuring its geology, and the orbital satellites collecting data would be thrust into a situation their designers never imagined. Researchers scrambled to analyze the shape and reflectivity of 3I/Atlas, hoping clues might explain the acceleration. Ground-based telescopes recorded fluctuations in brightness, suggesting an irregular, elongated form. However, unlike Oumuamua's sharp tumbling patterns, 3I/Atlas appeared to maintain a surprisingly stable orientation. The stability contradicted the idea of chaotic outgassing, which would normally cause random jets and spin. Instead, it behaved as though some hidden mechanism were keeping it aligned, like a gyroscope in deep space. Theories multiplied. Perhaps its internal structure included unusual crystalline lattices that interacted with solar photons. Or maybe it carried magnetic fields unlike any known in natural bodies. Whatever the mechanism, the fact remained, this object was not behaving like a traditional comet. The implications for physics were profound. Every time humanity encountered a phenomenon that bent existing rules, revolutions in science followed. Just as the bending of starlight during eclipses confirmed Einstein's relativity, so too could the peculiar acceleration of 3I/Atlas force a reevaluation of how interstellar bodies interact with stellar systems. Some suggested it might reveal previously unobserved properties of interstellar ice, compounds capable of releasing energy in ways unfamiliar to Earth-based laboratories. Others speculated about interactions with dark matter, an idea that typically occupied the fringes of astrophysics, but now seemed worth reconsidering in light of unexplained data. Mars served as both a canvas and a stage for these uncertainties. The planet had always been a mirror of human dreams, fertile ground for scientific curiosity, and a promised land for those who longed for expansion. Yet the very presence of 3I/Atlas in its vicinity forced a reconsideration of those dreams. Colonization is not simply a matter of building domes and habitats. It is a matter of surviving in a cosmos that can, without warning, send objects hurtling across millions of kilometers to intersect with human plans. Harvard's Astrophysics Division, in coordination with NASA's Planetary Defense Office, emphasized this point in their urgent communications. Their tone was clear. If Mars is to serve as a second home for humanity, then humanity must be ready to protect that home from the unexpected. The potential consequences extended beyond science and engineering into geopolitics. Space exploration has always been a theater of international rivalry and cooperation. And now, those dynamics became sharper. The United States, with its NASA programs, and China, with its accelerating ambitions, both have eyes on Mars. Europe, Russia, and private companies add further complexity. The approach of 3I/Atlas turned Mars from a competition of pride into a question of planetary security. Who would take responsibility for monitoring? Who would bear the cost of potential defensive systems? And if the nature of 3I/Atlas proved to be more than just geological, who would control the narrative of discovery? These were not idle questions. They were the foundation for future diplomacy in space. Meanwhile, engineers debated the feasibility of interception. With current propulsion technology, sending a spacecraft to chase an interstellar object is nearly impossible, especially one that is accelerating. By the time missions could be planned, constructed, and launched, the object would already be far beyond reach. Still, there were whispers in scientific circles about leveraging upcoming heavy-lift rockets or nuclear propulsion concepts. The goal would not be to divert or destroy, but to observe up close, to send instruments into its path and glean answers before it raced away forever. Such ideas remained largely speculative, but the urgency created by the Red Alert lent them a new gravity. There was also the philosophical dimension, impossible to ignore. Humanity has always wrestled with questions of solitude in the universe. The peculiar acceleration of 3I/Atlas touched that nerve directly. If natural explanations continued to fall short, then more radical ideas would demand attention. Could it be that interstellar space is not as empty as once believed? Could objects like this serve as carriers of messages, or worse, hazards deliberately sown into the galaxy? While mainstream scientists avoided such language, popular imagination surged with the possibility. Writers, thinkers, and even political leaders began framing the event in existential terms. If the cosmos contains actors other than ourselves, then the trajectory toward Mars might represent first contact in the most unsettling form. For astronauts training to one day step onto Martian soil, the news of 3I/Atlas struck deeply. They had spent years preparing for hazards like radiation, dust storms, and isolation, but not for interstellar bodies accelerating into their orbital neighborhood. Suddenly, mission simulations needed to include the possibility of incoming debris fields, redirected trajectories, or even emergency withdrawals. The challenge became not just physical survival, but psychological resilience. The knowledge that the universe might throw unexpected dangers into their path at any moment. Public reaction was equally intense. Media channels filled with graphics of the Martian orbit intersected by the path of 3I/Atlas, each one slightly different yet uniformly dramatic. Audiences consumed nightly reports, eager for updates, terrified by the word accelerating. Governments convened committees, both to reassure their populations and to extract advantage from the situation. For many, the Red Alert crystallized the idea that humanity was entering a new cosmic era, one in which the mysteries of interstellar space were not distant curiosities, but direct influences on our immediate future. Harvard's role carried special weight because of its history of bold astronomical speculation. Its astrophysicists had once proposed that Oumuamua might be artificial, a statement that stirred controversy worldwide. With 3I/Atlas, their restraint was greater, but their data was undeniable. They provided the numerical backbone of the Red Alert, showing that the deviation from expected paths was not an illusion, but a measurable, reproducible fact. NASA's agreement gave the claim institutional solidity, transforming it from speculation into accepted reality. The combination of Ivy League authority and governmental confirmation created a rare unity of scientific voice, ensuring that no one could easily dismiss the urgency. Attention also turned to the Martian moons. Phobos and Deimos, fragile rocks circling the planet, could be dramatically affected by even minor gravitational interactions. If 3I/Atlas passed too close, its pull could destabilize their orbits, generating cascading debris that would shower Mars with fragments. Such a scenario might not be globally catastrophic, but it would devastate delicate surface infrastructure and delay human exploration by decades. Engineers and scientists alike studied orbital models with grim focus, seeking to understand just how much risk these small moons faced. Beyond the immediate science, the cultural resonance deepened. Myths across civilizations have long spoken of omens in the sky, fiery visitors, and harbingers of change. 3I/Atlas, accelerating with uncanny steadiness, became a modern embodiment of those myths. It was both scientific data and archetypal symbol. Some saw it as a warning, others as an opportunity. Regardless of interpretation, it united people across languages and borders in a shared experience of awe and dread. Speculation about its composition grew increasingly detailed. Could 3I/Atlas carry materials unknown to the periodic table? Could it be made of hyperdense alloys formed in the violent furnaces of distant supernovae? Could it contain trapped gases that, when exposed to the sun's radiation, release exotic thrusting effects? Each hypothesis underscored one truth. Without direct samples, humanity was guessing, and yet those guesses mattered, because they shaped how we prepared for the future. If the object was natural, we needed new categories of astrophysics. If it was not, then we needed entirely new categories of thought. The very act of issuing a red alert symbolized a turning point. Science is often cautious, preferring understatement. For both Harvard and NASA to use such language meant they saw stakes too high for subtlety. That boldness carried consequences. It forced political leaders to take notice, compelled funding agencies to prioritize planetary defense, and stirred the imaginations of ordinary people who might otherwise ignore distant space phenomena. For once, the world's attention was fixed not on conflicts or crises of Earth, but on the silent, accelerating mystery approaching Mars. Even the timescale of the event reshaped human perception. Unlike distant cosmic phenomena that unfold over millennia, the approach of 3I/Atlas was unfolding in years, months, even days. It compressed cosmic time into human time, forcing decisions not in some abstract future but in the present. For scientists used to patient observation, this was disorienting. For the public, it was electrifying. The object's steady motion provided a countdown that everyone could understand. A ticking clock toward an unknown encounter. The data streams continued, and with them came refinement. Each observation narrowed the uncertainty. Each model sharpened the possibilities. The acceleration persisted, leaving no room for comfortable dismissal. In conference rooms and observatories, the mood shifted from curiosity to vigilance. If the object continued its course, the Mars we know, the Mars of rovers, satellites, and human ambition, would be altered forever. This is what made the Red Alert so extraordinary. It was not just about a rock in space. It was about the fragility of human dreams when measured against the vast and unpredictable forces of the cosmos. It was about the humility of a species confronted by mysteries it cannot yet solve. It was about the dawning recognition that Mars, our next step, is not isolated from the unknown, but is already entangled with it. The story of 3I/Atlas is still unfolding, and every hour brings us closer to revelation. Its acceleration continues, its trajectory sharpens, and the world waits. Mars spins on, oblivious to the drama gathering around it, while human eyes strain to interpret the signs. The Red Alert remains in place, not as a declaration of doom, but as a recognition that the universe has spoken, and it is up to us to listen. The declaration of a Red Alert regarding 3I/Atlas has already set the scientific community and broader world into a state of heightened awareness, but the ongoing implications extend even further when examined in greater depth. Each passing day brings not only new data, but also new interpretations of what this mysterious interstellar object means for our understanding of the universe and our place within it. The accelerating trajectory toward Mars is the focal point, yet surrounding that reality are layers of consequences stretching across disciplines, cultures, and generations. One of the most striking aspects of 3I/Atlas is how it redefines the concept of cosmic neighborhood. Until recently, humanity thought of its local space in terms of the solar system, the sun, planets, moons, asteroids, and comets that orbit within its gravitational influence. Interstellar space was the distant beyond, largely irrelevant to day-to-day scientific planning. With this object, that boundary collapses. The galaxy itself has intruded into our local stage, reminding us that our solar system is not an isolated bubble, but an intersection point along larger cosmic highways. This recognition is reshaping astronomy in real time, forcing a recalibration of what it means to prepare for and monitor celestial threats. The educational world is also transforming in response. Universities and schools alike are updating their teaching materials to reflect the urgency of the situation. Astronomy classes, once focused on static models of orbital mechanics, now include sections on unpredictable interstellar visitors. Physics students are asked to calculate hypothetical trajectories that take into account unexplained accelerations. Philosophy courses incorporate discussions on what it means for humanity to be confronted by phenomena that do not fit our current models. Young minds are being shaped by the recognition that the cosmos is alive with mysteries, not all of which can be comfortably categorized. This educational impact is paralleled by a surge of innovation in technology. Engineers and private companies are already brainstorming ways to build new classes of observatories capable of detecting interstellar bodies earlier. Space-based infrared telescopes, high-resolution interferometers, and even swarms of microprobes are being proposed as tools to ensure that humanity is not caught off guard again. The urgency generated by the 3I/Atlas alert is providing a rare alignment between public interest, government funding, and private ambition. The same synergy that once drove the Apollo program or the International Space Station is now converging on planetary defense and interstellar monitoring. At the cultural level, the appearance of 3I/Atlas has sparked a renaissance in art and storytelling. Novelists, filmmakers, and visual artists are drawing on the imagery of a mysterious, accelerating visitor headed for Mars. The symbolism is too rich to ignore. A foreign object entering our domain, immune to our expectations, moving with a will of its own. This imagery resonates with deep archetypes of intrusion and revelation. Museums host exhibits on interstellar exploration, while theaters stage performances inspired by the cosmic drama unfolding above. Humanity has always translated the heavens into myth, and 3I/Atlas is rapidly becoming one of the defining myths of our age. On the practical side, the potential risk to satellites orbiting Mars has driven urgent contingency planning. Communication networks linking Earth to Martian rovers rely on a delicate chain of orbiters. If even one of these were damaged by debris or disrupted by gravitational shifts caused by 3I/Atlas, the entire data pipeline could collapse. This possibility has triggered discussions about redundancy and resilience in extraterrestrial communication. Engineers are racing to develop backup systems, considering options like deep space relays stationed in safer orbits, or even quantum communication experiments that bypass traditional satellites. The objects approach is exposing vulnerabilities in the very architecture of interplanetary exploration. Another arena of impact lies in the realm of law and governance. Space law has always been a fragile framework, more aspirational than enforceable. Treaties like the Outer Space Treaty of 1967 were drafted in an era when the idea of interstellar visitors was little more than science fiction. Now legal scholars are forced to ask, who has the authority to act if 3I/Atlas poses a direct risk? Can one nation unilaterally attempt to intercept it? Would such action be considered a form of weaponization of space? These questions are no longer theoretical. They press at the boundaries of international relations. The arrival of 3I/Atlas is effectively rewriting the rulebook of space diplomacy. Psychology is another dimension where the object's approach exerts influence. People are grappling with a unique blend of existential anxiety and awe. For some, the thought of an unknown body accelerating toward a planet we intend to colonize triggers deep-seated fears of vulnerability. For others, it ignites a sense of cosmic wonder, a recognition that we are witnessing something rare and extraordinary. Therapists and cultural commentators alike note the parallels with earlier eras when comets or eclipses were seen as omens. Today, the difference is that we understand the science, yet the mystery persists, making it feel no less overwhelming. Religious interpretations have also emerged, as faith communities grapple with the meaning of the event. Some see 3I/Atlas as a divine sign, a test of humanity's humility in the face of creation. Others view it as a challenge, an opportunity to demonstrate stewardship of not just Earth, but the broader cosmos. Interfaith dialogues have begun to incorporate astronomical data into theological reflection, creating a rare fusion of science and spirituality. In this sense, the object has become more than a scientific puzzle. It has become a touchstone for collective human meaning-making. Economically, the implications are massive. Mars exploration has been an expensive endeavor, with billions already invested in landers, rovers, and orbital missions. The potential threat of 3I/Atlas forces reassessments of risk versus reward. Insurance models for space exploration, once abstract, are now being urgently recalculated. Private companies eyeing Mars for resource exploitation or tourism face the unsettling possibility that their business models could be disrupted by cosmic forces beyond control. Yet, paradoxically, the threat also creates new opportunities. Industries dedicated to planetary defense, early detection, and interstellar research are poised to expand dramatically. The scientific models attempting to explain the acceleration of 3I/Atlas are diversifying rapidly. One camp focuses on exotic materials. Perhaps the object contains compounds that, when exposed to solar wind, release propulsion-like effects. Another camp examines the possibility of interaction with magnetic fields, suggesting that the body's composition might include conductive layers capable of channeling energy. A third, more radical perspective considers whether the acceleration could be an intentional effect, hinting at origins outside purely natural processes. Each model sparks debate, but the urgency of the situation prevents complacency. The unanswered question of why continues to loom as the object closes the distance toward Mars. The ethical considerations are equally complex. Should humanity attempt to intervene, knowing that intervention might damage or destroy a unique scientific treasure? If 3I/Atlas is natural, destroying it would mean erasing data that could revolutionize astrophysics. If it is artificial, intervention could mean tampering with technology or signals beyond our comprehension. This ethical dilemma mirrors earlier debates about whether to send active signals into space to announce our presence. The difference now is immediacy. The visitor is already here, already accelerating, already altering our plans. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I/Atlas accelerating? Threat or natural space event? We want to hear from you. Thank you for watching and see you next time.